Okay, so I did these assignments just a little bit out of order. The last assignment for Module 4 is the 4.3 practice, and what this has to do with is solving linear quadratic systems. And if you look at the assignment, it's really just got two parts. It's solving linear quadratic systems algebraically and solving the systems with technology. Okay, so solving the systems algebraically. So what do? These really aren't very hard. Uh, you can use the same strategies to solve these kinds of systems as we did with the linear systems. But I think, so we could, in other words, we could, for example, use substitution here, because I can see that I've got a y up here that's equal to x squared, so the y is isolated. If I isolated a y down here, I could plug that in, or vice versa. So in this case, let's do this. Let me grab this picture. Oops. Okay, so I could take my pick. I could either use the top equation as a substitution equation, which really makes the most sense because it's already solved for y, and substitute that into the bottom equation. So let's substitute for y. Let's substitute x squared in the bottom equation, and what does that give us? Negative 4x plus x squared equals 0. Well, let's put that into standard form. So the x squared term goes first. And then I've just got a quadratic equation in standard form that I have to solve. And that's going to give me my x value. What I'm really wanting to find here is when, algebraically, I want to find the x and y values that make both of these equations true, which, just like in the previous, in the 4.4 practice, that's going to be the point where this line crosses that parabola. Okay, so to find the x value, I'm just going to solve this quadratic equation in standard form. So let's think about what our options are. When we have a quadratic equation in standard form, if there's a single value of x, we isolate it. But here I've got two separate x values, so I can't do that. If I've got an x squared and an x in my equation, then really there's two things I could do. The first thing I always want to try to do is look for magic numbers. If there are magic numbers, or if I can factor this very easily, then that's the quickest way to do it. If I can't factor it simply, then I'm either going to use the quadratic formula, or I'm going to complete the square. You take your pick, but I think most people are going to want to use the quadratic formula. But in this case, this is much simpler. This is one where we don't have to get complicated like that. We can just factor this. If I factor out an x, if I undistribute an x, I get x times x minus 4 equals 0. And now I've just used the zero product property. Once I get this thing factored, remember I asked, what's the value of x that makes the first factor equal to 0? Well, 0. What's the value of x that makes the second factor equal to 0? 4. 4 minus 4 would be 0. And remember that the product of these two factors can only equal 0 when I'm multiplying by 0. So either the first factor or the second factor has to be 0. So my two possible solutions are x equals 0 or x equals 4. Okay, so it looks like there are going to be two places where this line intersects the parabola. One is going to be when x is 0, and one is when x equals 4. I need to find the y values that go with each one of those. So what about when x equals 0? Well, I'll go back to my substitution equation, and y equals x squared, so y would just equal 0 squared, which is 0. So one point is going to be at 0, 0. What about the other point? When x equals 4, y equals x squared, so that's going to be 4 squared, which is 16. So the other point is at 416. I'm just substituting each of these x values back into my substitution equation to find y. And so I'd have to enter both of those points. And what's it tell me to do? It wants me to, if multiple solutions exist, separate them with commas. So I've got two separate solutions, 0, 0, and 4, 16. And so we would just enter it like this, 0, 0, comma, 4, 16. In either order, it doesn't matter. Okay? Let's look at another one. And that's really all these are. They're just, it's a bunch of examples of kind of the same thing. So this is just sort of a tricky way for me to get you guys to do solve some quadratic equations in standard form and get some additional practice with that. What about this one? We could use substitution here as well. I've got this top equation is already solved for x, so I could substitute the quantity y minus 1 squared in for x in the bottom equation. So if I do that, what's the bottom equation give me? It gives me y minus 1 squared, quantity squared, plus 3y equals 7, right? I'll tell you what, let me take a picture of this. Okay, so how do I expand this out? Well, there's two ways we can do this. If there's a trick that I'll show you, which I think is kind of handy. Whenever we have something of this form, I have something plus or minus something else and it's being squared, there's a pattern that we can follow. Here's the pattern. In general, if we just say we have something like a plus b squared, the pattern is it's always equal to the first term squared plus 2 times the first term times the second term, so 2ab plus the second term squared. I could also always just multiply them out manually. Okay, so what does that give us here though if we use this pattern? So instead of an a we have a y, instead of a b we have a -1. So this whole thing is just going to become a squared is going to be y squared plus 2 times y times -1, right? 2 times a times b is going to be -2y. And then instead of a b we have a -1. -1 squared is 1. So that's what that would give me. If that doesn't, I'll talk more about this when I'm with you guys at school. If that doesn't make sense, you don't have to do it that way. We could also just say that y minus 1 squared equals y minus 1 times y minus 1. You can always fall back on this and just distribute. So we could distribute the y to both terms and get y squared minus y, and then distribute the -1 and get minus y, -1 times -1 is +1, and if I add up those like terms, -y plus -y is just -2y. Either way, I'm going to get the same answer, aren't I? So y minus 1 squared becomes y squared minus 2y plus 1. Then let's just continue with the rest of the equation. So plus 3y equals 7. Get rid of all this stuff. And now all I've got to do is just simplify this, put it in standard form and solve. So let's combine like terms. I get y squared, -2y plus 3y is plus y. And then if I subtract 7 from both sides, I'm going to get minus 6 equals 0. All right, if I just combine like terms. Okay? So now I've got a quadratic equation in standard form. Remember, the first option, if we can find magic numbers, let's see if we can. So are there magic numbers? Let's just see if we can factor this. So are there magic numbers that multiply to -6 and add to 1, because 1 is the coefficient of y? Yeah, there are. -3, actually +3 and -2, right? positive 3 and negative 2, multiply to negative 6, and add to positive 1. So there is my quadratic equation in factored form. So we factored it, and now all we have to do is just apply the zero product property, meaning we just have to find the values that make each of the two factors equal to 0. So what value of y makes the first factor equal 0? Y plus 3 equals 0 when y equals negative 3. Y minus 2 equals 0 when y equals positive 2. And then to find the corresponding values of x, let's go to the bottom equation. And we'll plug in these y values and solve for x. How about? Okay, so that's an easier one because it's linear. Nothing is being squared. So if I plug in y equals negative 3, what does this equation become? X equals 3, x plus 3 times y, which is negative 3, equals 7. So x minus 9 equals 7. If I add 9 to both sides, x equals 16. So one point is going to be x equals 16 and y equals negative 3. So there's one ordered pair. There's my x value, there's my y value. What about this other one over here? Y equals 2. So once again, if I take the bottom equation and I plug in y equals 2 into the bottom equation and solve for x, what do we get? X plus 3 times 2 equals 7. X plus 6 equals 7. Subtract 6 from both sides. X equals 1. So then I get the ordered pair. X equals 1, y equals 2. And I just need to enter those separated by a comma. Okay, so what were those again? 16, negative 3, and 1, 2. Okay, it's really late at night, sometimes really late at night. It takes forever. Okay, so we got it. All right, here's another example. Let's try this one. Okay, so what about this one here? So we could, for example, easily isolate y in the bottom equation and plug that into the top equation, right? The other thing we could, well, this is a good example. I'll show you one other technique with one of the other problems here. So let's take this bottom one and let's solve for y. So I'm going to add 3x to both sides. And so if I do that, what do I get? Well, I'm going to get y equals 7 plus 3x, or probably better would be to say 3x plus 7. So there's my substitution equation. Let's plug that into the top equation. So instead of a y, we're going to plug in the quantity, 3x plus 7. So what does the top equation become then? So we get x squared equals negative the quantity, y, which is 3x plus 7 plus 2. Okay, so if I simplify this, I just end up with the equation x squared equals, if I distribute the negative 1, negative 3x minus 7 plus 2. So x squared equals negative 3x. Negative 7 plus 2 is minus 5. And then I'll put it in standard form. I'll just add 3x to both sides and add 5 to both sides. And if I do that, I just end up with x squared plus 3x plus 5 equals 0. So effectively, I just moved these terms to the other side of the equation, right? And so now, here's my quadratic equation in standard form. X squared plus 3x plus 5 equals 0. This time there are no magic numbers. There are no numbers that multiply to 5 and add to 3. And so we've got to fall back on plan B, which is the quadratic formula. So a quick reminder of the quadratic formula. So the quadratic formula says that if we have a quadratic equation in standard form, so ax squared plus bx plus c equals 0. So for us, a is 1, b is 3, c is 5. Then we know that x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. Okay, now in this case, the question asks us to find all the real solutions, right? The real solutions. So real solutions are going to be the ones where there are no i's. And so remember, we called this part that's under the square root in the quadratic formula, we called that the discriminant, right? So a lot of times we'll label that capital D. And this goes back to last module. The discriminant D is just b squared minus 4ac. It's just the part under the radical. Well, if that ends up being, if the value of b squared minus 4ac is negative, I'm going to get i's in my answer, and that's not going to be real. Those will be imaginary. And so the first part of this that we might want to look at is what's the value of the discriminant going to be. So when we're solving for x in this equation, x is going to equal negative 3 plus or minus the square root of b squared, so 3 squared is 9, minus 4 times a is 1 times c is 5, all divided by 2 times 1 is 2. But look what we get there. The part under the radical is 9 minus 20. Well, that's negative. And so I can tell right away that I'm going to get i's in my answer. So I can stop. I can stop right now because b squared minus 4ac gives me a negative number under the radical. I am not going to get any real solutions. And so we can just enter false. Okay. Okay, another one, very similar. In this case, we've already got a substitution equation in our second equation. So I can substitute negative 4y plus 23 for my x in the top equation. And what's that give me? And the top equation becomes the quantity y minus 4 squared equals negative the quantity negative x, and x, remember, is just going to end up being the quantity negative 4y plus 23 from our substitution equation plus 4. Okay, and so whichever way you want to do this, we can either just distribute, write this as y minus 4 times y minus 4 and distribute, or we can use our little trick. Remember our little trick. A plus b squared equals a squared plus 2ab plus b squared. Either way, this is just a lot quicker. That means that this is just going to become y squared plus 2 times y times negative 4 is minus 8y plus negative 4 squared is 16. Or, like I said earlier, we could also just write it that way and distribute. Either way, we're going to get the same answer. So what do we get on the right side? If I distribute the negative sign, negative 1 times negative is positive. So I get a positive 4y minus 23 when I distribute the negative 1 to the 23 plus 24. And so the equation becomes y squared minus 8y plus 16 equals 4y minus 23 plus 4 is minus 19. So let's put it in standard form. We'll push everything to the left side, so I'll subtract 4y from both sides and add 19 to both sides. So everything cancels on the right. On the left, I get y squared minus 12y plus 35 equals 0. And so then the question is, can we find magic numbers? And we can this time. What numbers multiply to 35 and add to negative 12? Negative 7 and negative 5. So we could use magic numbers, which gives us the solutions y equals 7. That makes the first factor equal to 0, or y equals 5 makes the second factor 0. Okay, what if I didn't see those magic numbers? I could have also used the quadratic formula if I wanted to. I could have said a is 1, b is negative 12, c is 35. And then just use the quadratic formula. And the variable I'm solving for this time is y instead of x. So y would equal negative b, which is positive 12, plus or minus the square root of b squared. So negative 12 squared, we just make positive 12 squared, remember. We always, whenever we square a negative, just square the positive instead. Minus 4 times 1, we won't even write that, times 35, all divided by 2 times a. 2 times 1 is 2. And so what would that give us? We could use a calculator for this, probably. We'd get 12 plus or minus the square root of 144 minus 140, all divided by 2. And so we get y equals 12 plus or minus 144 minus 140 is 4. The square root of 4 is 2 over 2. So if we take the plus, we get y equals 12 plus 2 is 14 over 2 is 7. If I take the minus sign, I'd get 12 minus 2, which is 10 over 2 is 5. Either way. Okay. But it's quicker to do it this way, just using the magic numbers. Okay, so whichever method we use, once I find the solutions for y, then remember all we've got to do is go back into our substitution equation and find the corresponding values of x. So when y is 7, then x would equal negative 4 times 7 plus 23. So x would equal negative 28 plus 23. X would equal negative 5. So one solution would be the ordered pair. X is negative 5, y is 7. What about the other solution? So when y is 5, x would equal negative 4 times y, which is 5, plus 23. So x equals negative 20 plus 23, x equals 3. So the other solution would be x is 3, y is 5. Okay? Okay. What were those again? Negative 5, 7, and 3, 5. Okay? And then last one. Okay, so this one we probably would want to solve for y. And let's talk about that for just a second, why that's the case. Okay, so we want to substitute for y because that's not being squared. So the x is inside this quantity that's being squared. So we would really want to take this bottom equation and isolate y. So I could just subtract x from both sides, and we end up with then y equals 15 minus x if I subtract x to the right side. So there's my substitution equation. That's what I'm going to substitute for y in the top equation, right? Because y is not in the part that's being squared. So that's what I want to substitute for. So what do we get then? So the top equation becomes negative 4 times the quantity x plus 6 squared equals y, which remember is going to be 15 minus x minus 10. And so then we'll just simplify this. So this is the equation that we're going to have to simplify. So we get negative 4 times x plus 6 squared. Okay, so last time I used the shortcut. This time let's just multiply that out. Let's just distribute. So that's the same as x plus 6 times x plus 6 equals 15 minus x minus 10. Okay, so let's distribute this part right here. Let's just focus on this part, and then we'll distribute the negative 4 when we're done. So let's distribute the x to both parts of the second factor, and that's going to give us x times x is x squared, x times 6 is 6x. Let's distribute the 6 to both parts. 6 times x is 6x. 6 times 6 is 36. And now we've got this negative 4 times the whole product. So now, after I simplify this, I'll distribute the negative 4 through. If I had wanted to, I could have multiplied the negative 4 times the first factor and gotten negative 4x minus 24, and then distributed those bigger numbers. But I prefer to do it this way. I like to leave the negative 4 out front and then distribute once I've cleaned all this stuff up. Right? So here's when I distributed the x plus 6 times the x plus 6. This is what I get. On the other side, we've just got 15 minus x minus 10. 15 minus 10 is 5. So just 5 minus x. And then on the left side, 6x plus 6x is 12x. So I get x squared plus 12x plus 36 times negative 4 equals 5 minus x. And now I'm just going to distribute this negative 4 to each of those three terms. Yeah, okay. So that gives me negative 4x squared minus 48x, and then negative 4 times 36 is minus 108 equals 5 minus x. Okay, so let's push everything to the left, so I'm going to subtract 5 from both sides and add x to both sides. And then we get 0 on the right. On the left, we get negative 4x squared minus 47x minus 113. Okay, this is something I want to really point out here. We never want to have a negative value of a. So we're going to multiply each side of the equation through by negative 1. The right side just stays 0, but that just changes the signs of each of the terms on the left side. We always want a to be positive, so we get 4x squared plus 47x plus 113 equals 0. And so that's looking pretty bad, but we would just apply the quadratic formula. Here's all we would do. So here's the equation I'm solving for x. And so applying the quadratic formula, so we know a is 4, b is 47, c is 113, and we get, remember we get x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Well, let's check the discriminant first, the sign of the discriminant, to just see if we're going to get a positive or a negative value. Okay, and if we do that, I'm just going to use my calculator here. Okay. Okay, I see I made a little mistake here. I was wondering what was going on. This wasn't working out as well as I wanted it to, and I made a little mistake. I got careless here. Negative 4 times 36, I did 3 times 36. Negative 4 times 36 is not 108. So we got to go back. Let's go back a little bit. And this happens in math. All right, so we backed up a little bit to the place where I was simplifying my equation for x. When I distributed the negative 4, then I should get the equation negative 4x squared minus 48x minus 144 equals 5 minus x. Okay, so I'm going to subtract 5 from both sides, and I'm going to add x to both sides. And then I end up with negative 4x squared minus 47x minus 149 equals 0. I'm going to multiply each side through by negative 1 to change the sign, so that becomes a positive 4x squared plus 47x plus 149 equals 0. And so I want to find the solutions of that. All right, so this is the quadratic equation that I'm solving. That looks pretty bad. So what I'm going to do is we're going to use the quadratic formula. Right, so in this case, A is 4, B is 47, C is 149. We're only looking for real solutions. So when I apply the quadratic formula here, x equals negative b plus or minus square root b squared minus 4ac all divided by 2a. I'm going to check the value of that discriminant to just see if I have to go through this whole hassle. So let's try this. B squared minus 4ac is going to give me what value? That's 47 squared minus 4 times 4 times 149. Let's see what that gives me if I put that in my calculator. So 47 squared minus 4 times 149 is negative 175. And so because the discriminant is negative, I'm going to get i's in my answer. I've got a negative number under the radical, and so I'm going to get no real solutions. Remember, if the discriminant's negative, a quick review from Module 3, remember that if the discriminant is greater than 0, we get 2 real solutions. If the discriminant equals 0, then we get 1 real solution. And if the discriminant is less than 0, if it's negative, we get 0 real solutions. Instead, we get two complex solutions with imaginary parts. They've got i's in them. So for our purposes here, though, that makes things pretty simple. We know that because I'm going to get i's in my answer, we're only looking for real solutions, and so it's false. Okay. Last two, solve the system with technology. Okay, so then this is the same kind of stuff we were doing in section 4.4. So all we're going to do here is just solve for y into the calculator, and we'll graph these two functions and see where they intersect. So let's make the top one y1. If I get y by itself, I'm just going to subtract 4 to the other side. Right, so what we end up getting is y equals the quantity x plus 1 squared minus 4, right? And I don't have to be fancy with this. I don't have to simplify. The calculator does not expect that I will. It doesn't need me to. So let's flip this around. So how about if we put the y plus 4 on the left side and the x plus 1 squared on the right side. And then I'm just going to subtract 4 from both sides and get y equals x plus 1 squared minus 4. So there's my first one. Second one, all I have to do is subtract 3x from both sides. So if I graph those, if I graph the quantity x plus 1 squared minus 4, right, because that's what y1 was right there. If I isolate y in the top equation, isolate y in the bottom equation, I'm just going to start with, remember how we did this last time, we start with a negative 17 on the right side, and I subtract 3x, and then divide by 1, which doesn't change anything. So I can just leave it like that if I want to. I don't even need the parentheses in this case. And I'm just going to go, how about if we go zoom standard, just see what it looks like. And so what do we see? Well, the line never intersects the parabola, and so the answer is false. Oops. Okay, last problem. What about this guy? Same kind of thing. Let's solve the top equation for y. So if I solve the top one for y, I'm just going to get the quantity x plus 6 squared plus 3. If I solve the bottom one for y, I just get negative 4 plus 3x. Zoom 6 to start with, see if we can see the intersections. Okay, and that one ends up being false also, turns out. Okay. Oh. Wrong. What'd I do? Plus 3x. Oh, whoops. Should be x minus 6 squared, and I put x plus 6 squared. So we got to make that x minus 6 squared plus 3. Let's try this instead. Okay, so there's one solution, but it looks like there's going to be another one up here somewhere. So I'm going to have to maybe change my window a little bit. Let's go from, how about if we let the window go from, I could just make the left edge of the window at 0, and the right edge, how about, let's just try 10. Actually, let's make it 15. And then I'm going to let the calculator pick the y values. So I'll go zoom 0. Okay, and now I can see both intersections. And if I want to find those, all I've got to do is go second, calc, intersect. And so, yeah, first curve is the parabola, y1, second one is the line. And now I do have to make a guess because there are two separate solutions. So I'll just trace up here close to this intersection and hit enter. Okay, what's it want me to do here? It tells me round to the nearest hundredth. So one solution, round to the nearest hundredth, I get 11.14 is my x value. And the y value is 29.42. Okay, what about the other one? Got to repeat that process, intersection process. So second, calc, intersect. First curve, second curve, but then I have to make a new guess. I got to go down here close to the first intersection. Okay, and that gives me the point 3.86 rounded to two places and 7.58. Oops, I gotta copy those. There we go. Okay, and that's it.